All right, let's get started. So today I'm going to talk about the randomness in computer simulation. So what does randomness mean? Randomness basically is just meaning unpredictable upcoming things or events or behavior in the simulation system or even in the games. So technically definition is events with no pattern. Uh, it's no certain module that we can predict events. So that's non-predictable, no predictability. So in mathematical definition, that means chance of every possibility in set of possible events is equal. So every event could be happen or could be not happen. So the possibility is totally, highly, equally likely. So like imagine a rolling a dice or throwing a coin. So the number of dice or which side of coin facing up is the possibility is quite equal. So every number is 1 over 6 or it's 50% of possibility. That's randomness means unpredictable things or unpredictable events. Randomness in simulation. So this is a traffic simulation. So like we're going to load traffic into this highway, but which type of next upcoming vehicle is totally random. And if we want to make the simulation more close to the realistic, we need to add some like exceptions like traffic traffic accident or the weather influence. So those things like those chances or possibilities is randomness. So basically, randomness in simulation, it itself is a manipulable abstraction of the objects being simulated. So the thing itself is controllable, is predefined, it's set up. The randomness is set up in the simulation system. We can control the randomness. We can play with randomness as a property of objects. So it's a way to represent uh, the complex of process. Well, this randomness may not be essential to the simulation. It's not the major behavior, but it shows a sense of reality, a complexity, or presence to the simulation. So randomness in simulation is functioning as an important part to make the simulation be realistic. But on the other hand, randomness in game is quite different. Well, of course, it's again a manipulable abstraction of the objects, but also the main purpose is to add complexity, to add unprediction to the game so that the game could be more fun, like in this example, like Tetris. So if the player knows what item would come for next one, then the game would be totally boring. So randomness just add more entertainment to the game. That's, well, basically probably the essential to the game. So we're talking about what's role to anchoring events. Well, the time to anchor events is basically quite a fundamental. If we remember the case of hot dog stand, we need to timing the customer arrival, the customer leaving. So in between there is the service time. Without time, we cannot mark the anchoring events. Also, it is a key element of anchoring events. So what's the time for the inter arrival? So that we can predict when will be the next customer arrive, and in the total period of time that we're doing simulation, we can know the system of the percentage of customer showing in the period of time. So that's quite important. Uh, Basically, that means time is the x-axis of simulation. So what's the randomness to a simulation? Well, we need to know the fact that randomness is a property of a sequence of events, not a single one. And of course, simulation itself is a complex process. So randomness is the important property to make it real. Imagine that if 100 customer shows in 1 minute and leaves the hot dog stand to be idle for entire rest of day, that's not real. So we just add properly randomness to present the realistic of a simulation. So how does randomness apply to my project? My project is going to present a gas diffusion. So every gas molecules would be moved as Brownie moving. So that means that every next step is unpredictable. How does the gas molecular move for next direction is random. So um, for now, I can tell is I would add randomness to my gas molecules moving as so that present the Brownian moving movement, so that I can uh, show my simulation as more close to reality. So that's everything from talking today. Thank you for listening.